Okay, so in this third video, we're going to continue talking about circle concepts. And what we're going to talk about in this video are angles related to circles, okay? And so just a couple things I want to remind you. An angle is a geometric object that's typically made up of 3 points. And we write it with this symbol right here. That's the angle symbol. So here we say angle, angle, A, B, C. And the middle letter is representing the point of the vertex. All three of these are points. A, B, and C are points. Here's point A, here's point B, and here's point C. And what we have is an angle is made up of 2 rays or segments. So one of them is AB, so here's AB right here, and then the other one is BC. BC is right here, okay? So this is a ray and this is a ray, or they're segments that just go from B to A, all right? And the place where the 2 lines meet up, or the 2 rays or line segments, the point, that's a shared point. This point B, is shared by AB and also shared by CB. So where they meet up, that's called the vertex of the angle, okay? And that's sort of where the action happens. That's where the measurement of the angle occurs, okay? And so we have 3 kinds of angles that we're going to look at related to circles. We're going to look at what's called a central angle. We're going to look at what is called an inscribed angle. And then we're also going to look at what we call an exterior angle. So let's jump into those now. Okay, so the first kind of angle we're going to look at is called a central angle. The reason it's called a central angle is because the angle happens at the center of the circle. So here we have circle E. The center of the circle is point E. And the definition we're going to go with is here, it's an angle that's created by 2 radii. So if you have 2, and this word radii, I know that's weird, it's a Latin thing. Radii is the plural of the word radius. So some people might just say radiuses. Okay, so look, we have 1 radius, 2 radiuses, but we don't say radiuses. We say radii. So we have 1 radius, and then another radius means that we have 2 radii, okay? And since all radiuses share, have an endpoint at the center, what we have here is this line right here is line segment DE. This line segment here is line segment EF, okay? And so EF and DE both have E as an endpoint. And that makes this, and since E is the center of a circle, that makes it a central angle, okay? And here's the interesting thing, well, something you need to remember about central angles is the vertex is always at the center of the circle. So E is the vertex, and here is the angle right here, okay? And so here's how we would write it. Angle, and we're going to say D, then E, then F. Angle D, E, F is a central angle of circle E. And it'll always be this letter. Whatever this middle letter is, that's the name of the circle because that's the center of the circle, okay? Now, one more thing I want to show you is, do you see how point D and point F both are on the circle because they're radii, and therefore they actually cut off an arc. They create an arc right here. They create this arc right here, and therefore that arc is an intercepted, that's an intercepted arc, okay? So arc DF is the intercepted arc of angle DEF, and that'll happen very frequently, okay? All right, now let's talk about what's called an inscribed angle. An inscribed angle is an angle that's created by 2 chords, okay? So central angle is 2 radiuses or 2 radii. They make an angle. Well, this is where 2 chords make an angle. Now, in order for that to happen, they have to share an endpoint. So you can see here, here's chord AB, so line segment AB, that's a chord because it goes from A on the circle to B on the circle. But you can see here, here's another chord, AC is also a chord. A line segment AC is a chord because A is on the circle and C is on the circle. And notice, because both of these line segments share an endpoint, okay, they are going to create an angle at that shared endpoint. And so here, there's an angle right there, okay? And A is the vertex of that angle, okay? So what we have here is angle BAC. So angle BAC is an inscribed angle. Inscribed angle, okay? And this is the angle right here, okay? Now, notice if we go to the other two endpoints, if we go to B and C, because they're both on the circle, they cut off an arc. See this here? They cut off an arc. And so that means that this arc right here, okay, from C to B, so that's arc CB, or we can call it BC or CB. Arc BC is an intercepted arc, or it is the intercepted arc of angle BAC. All right, so the last kind of angle related to circles that we're going to talk about is called an exterior angle. Note that there are other kinds of angles related to circles, but we're only going to look at these three kinds. If you can understand these three kinds of angles, then the other kinds of angles are going to be really easy to understand as well, okay? So an exterior angle is an angle that is outside of the circle. Okay, so the last two angles we looked at, the central angle and the inscribed angle, are inside of a circle, but this exterior angle is outside of a circle, and it's created by the intersection of either two tangents or two secants or a tangent along with a secant, okay? And so let me show you this example over here. Okay, you can see line QR, Q and R are both on the circle, so this line cuts through the circle. It's inside the circle right here, so that makes it a secant. Okay, so QR is a secant. And then PS, line PS, this is also a secant because it's inside the circle. Now, these two secants, they intersect at point G right here. And so look, it creates an angle right here. Now the exterior angle is always the angle that's sort of facing the circle, okay? So this angle is not the exterior angle, this is not the exterior angle, and this is not the exterior angle. It's this one right here, okay? This angle is the exterior angle of the circle, okay? And it's created, like I said, in this case, by two secants. So we would say that angle, well, how could we name it? Let's name it P, then G, then Q, okay? So angle PGQ is an exterior angle. Now, what's interesting about exterior angles is they actually create two intercepted arcs. So look, Q and P both intersect or are both points of intersection of the secant and the circle. And so this right here, this little arc right here, arc PQ, so arc PQ, that's an intercepted arc. But look, the secant also has R and S. And so between R and S, which is this spot right here, so that arc right there, arc RS, is also an intercepted arc. And so exterior angles usually have two intercepted arcs.